BigDL 2.0 is an open source project which can help users to transparently accelerate the model training and inference pipelines on laptops and seamlessly scale local code to handle massive data on a large cluster. BigDL 2.0 includes a bunch of libraries to ease the building of AI applications. As shown in this block chart, at bottom level, we have the Nano library, which provides transparent acceleration of PyTorch and TensorFlow applications on laptops and workstations, and the Oka library, which helps users to scale local code seamlessly to a distributed cluster, and the DLlib library, which is a distributed deep learning library for Apache Spark. At higher level, we provide several toolkits which further helps users to easily build domain-specific applications, such as PPML for privacy preserving machine learning, Chronos for time series analysis, and Frisian for recommendation systems. In this introduction, we'll focus on the two key libraries, BigDL Nano and BigDL Oka. BigDL Nano integrates various modern CPU accelerations for TensorFlow and PyTorch, and they are automatically enabled and configured according to your platform. The integrated accelerations include better memory allocator, proper environment variables, AVX512, BF16, multiprocessing, optimized inference engine, and quantization. Enabling and configuring each of these tools and accelerations would otherwise require considerable experience and efforts. With BigDL Nano, you only need very few code changes to enable these accelerations so that you can run TensorFlow or PyTorch experiments much faster on your laptop or workstation. To install BigDL Nano, you need only one pip install command for either TensorFlow or PyTorch. Then you just need very few code changes to enable the accelerations in training and inference. Next, let's check out some code examples. To accelerate the training for a standard PyTorch Lightning program, all you need to change is to import the trainer from BigDL Nano instead of the standard PyTorch Lightning library. To enable multiprocessing and Intel PyTorch extension optimizations for training, you can set the number of processes and set use IPEX to true in the trainer. You can use BigDL Nano to accelerate the model inference as well. As shown in the example, for a standard PyTorch Lightning inference pipeline, what you need to do is first import the trainer from BigDL Nano, then use trainer.trace to get an optimized model for inference. In this example, we use OpenVINO as the accelerator for trace. You can also use BigDL Nano to do quantization. For a standard PyTorch Lightning inference pipeline, what you need to do is first import the trainer from BigDL Nano, then use trainer.quantize with precision set to int8. You can use an accelerator for quantization. In this example, we used the Onyx runtime. By applying simple code changes as shown in previous examples, you can get substantial speedup using BigDL Nano. According to our experiments, BigDL Nano can bring up to around 6 times training speedup and around 10 times inference speedup. Finally, when you are ready to deploy your prototype to process larger datasets, you can use BigDL Oka to scale it out to a distributed cluster. BigDL Oka can help you ingest various types of distributed data format from remote storage, perform distributed data processing, distributed model training, and distributed model inference. Using BigDL Oka is also easy. For example, to do distributed training, you can simply create an estimator to take a normal PyTorch or TensorFlow model. Estimator.fit will automatically train the large dataset in a distributed fashion on the cluster. You're welcome to explore more about BigDL 2.0 at these links. Thank you very much for watching.